All right, guys, we are going to learn about graphing the sine and cosine functions today. And in the same lesson, we're going to learn about amplitude and period changes as well. So I am kind of hoping you've all seen this at some point. In Honors Algebra 2 last spring, I know this was taught with remote learning, so I'm concerned that some of you have not done this, which could be a challenge. If you are coming from regular Algebra 2, you should have had the trig course at some point, so you should know this from that course. Okay. The sine function graphs the vertical change as theta rotates around the unit circle. So remember, we just had a lesson where the sine is the y values. So I'm going to use two different colors here, but as we start to rotate, right here, y is 0. Then as we rotate around the unit circle here, from here, the y would be this tall. And as we went to here, the y would be this tall, and this tall, and this tall, and this tall, and this tall, until the y value gets up to, right up here, the tallest y value has a y value of 1. So if I were to go over here and draw those, starting here it was 0, then it got taller, 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 till it got up to 1. Okay? And that happened at pi over 2, which is 90 degrees right here. Now the y values start getting shorter again over here, but not very fast, okay? They are getting shorter and shorter and shorter and shorter and shorter till they get back to 0. So they are doing this. Okay? So those are the y values. Now, as we continue to rotate around the unit circle, down here, the y was at 0. Now the y starts to go, as we're rotating around here, remember, the y is getting longer, but it's getting negative. So those are negative y values all the way till we get to y is negative 1. So it's at 0, and then it starts getting a little negative and a little more negative, all the way until it gets to negative 1. Then as we move into this quadrant, it starts at negative 1, and then the y values, as we rotate around here, like this y would be short, right? So the y values are getting shorter until they get back to 0. All right, so those little lengths of the sticks help us to see that this got taller until it was at 1, and then it got shorter till it was back to 0. And then it got negative until it was at negative 1, and then it got shorter until it was back to 0. Okay, I didn't do a very good job here matching my graph. But all the way around would be a value of 2 pi. Halfway around here, where it switched from red to blue, or positive to negative, was pi. Where it hit a peak here was pi over 2, and down here at the bottom is 3 pi over 2, and that would be here, or 1.5 pi, or 270 degrees. But we always measure, this is theta in radians. Okay, and this was the sine value of that radian measure. Now, I do need to tell you, you can continue to rotate forever, and so this graph continues on. Didn't do a very good job over here. It is periodic, meaning it repeats and has a period or a length of time at which it takes to repeat. Before I do cosine, I want to show you this real fast. This is the sine graph, okay? The sine is the red. Do you see how the red changes as you go around here? It gets longer, shorter, negative, and it's doing the same thing over here. Just an animated example of this. All right, cosine, on the other hand, I'm sorry, the cosine graph, let's use green. The cosine is the x value. So if this ordered pair is 1, 0, here at 0 radians, we're all the way over here at 1 for an x value, because cosine is x. So it's how far. Now we're going to put it this way because this is the cosine of theta and this is theta. But it's how far you went over. So we went over a whole unit, and then we went over almost a whole unit, and then the over part, the x value, keeps getting shorter and shorter as we go around the unit circle here. So as I rotate around, the amount I had to go over is decreasing until it gets all the way to nothing. I didn't have to go over at all when I got to pi over 2. So my x values, which on here are now the value of the cosine, was getting shorter until it got to 0 at pi over 2. Now, when you move into the next quadrant here, x is going to the left, so the cosine is negative. We're going more and more and more and more and more negative until at pi we're going all the way -1. So we're going more and more and more and more and more and more negative until at pi we're all the way down to -1. All right, then in this quadrant we are still going left a lot, and then as we rotate around, like to here, you've only gone left that much. Here you've only gone left that much. So as you rotate around, the amount you had to go left got shorter and shorter. Okay, my sticks are really bad over there, sorry. Okay. And then as we move into quadrant 4, so here we are at 3 pi over 0, or 3 pi over 2, and we didn't have to go left at all. So that was 0. But then as we move back into this quadrant, our left-right is very short, but getting longer, but it's going right, which is a positive direction. And it keeps getting longer until it gets back to 1. So our left-right length was getting longer and longer until it got to 2 pi, at which point it was back to 1. All right, so this function would repeat this direction, okay, and keep going this way. And because it's doing this, it has y-axis symmetry, so it is an even function. The parent function here for a cosine is an even function. Was that on this one and I skipped it at the bottom? All right, the sine function, when you had the overall shape here, the sine function is like this, which remember could be rotated 180 degrees and would look the same. So that's origin symmetry. So this is an odd function. Now that will change depending if we shift it, but the parent function is odd for sine. So cosine starts at the maximum, whoops, and sine started at 0. All right, so here they are graphed, and I just want you to label a few things on these notes. This ordered pair, you're going to have to do what are called quarter points. You're going to have to tell me the ordered pairs for 5 points in one period. Okay. So you're going to start at 0, 0, and then you have to tell me the next 4 points until it's back to where the period starts over again. So this is pi over 2, and it's up at 1. This one was 0, 0. This ordered pair right here is pi 0. This guy at the end is 2 pi 0. And in between 1 and 2 would be 1.5, or 3 halves, 3 pi over 2, 0. -1, just kidding. All right, so it went up, back to 0, down, back to 0. And going this way, this would be negative pi over 2, negative 1, pi 0, or negative pi 0, negative 2 pi 0, and this would be negative 3 pi over 2 and up 1, okay? I don't really care if you write those down. This is the amplitude, is the height, the maximum height or maximum here. It is the difference above and below the midline. So that's called the amplitude. And the period is the length of one cycle. So the length of time it takes anywhere, you can start anywhere. You could go here to here. From negative 3 pi over 2 to positive 1 pi over 2 is one period, or from 0 to 2 pi. So the period is 2 pi. That's because it's the length of one cycle, and it doesn't matter where you start. I could start right here, okay? Go all the way up, down, and back to that same spot again, and that distance would be 2 pi. That's a little confusing. I probably should have not explained that way, but all right, cosine, same graph, except shifted a little bit so that it starts at its maximum. So this is 0, 1. Then here we cross a quarter point at pi over 2. We cross the x-axis. At pi, okay, down here, the amplitude shows that we are down at negative 1. So this is pi negative 1. It's supposed to be a comma, sorry. All right, this one is 3 pi over 2, 0. And then it's back at its maximum here at 2 pi 1. So this shape repeats. So the period is this length, and measured anywhere along here from start to finish. So that's 2 pi till it starts over again. And the amplitude is how far above and below it's going. So this one is going down to negative 1 and up to positive 1. So the amplitude is 1. All right, notice the cosine is a horizontal translation of the sine. Any transformation of a sine function is called a sinusoid. Therefore, both sine and cosine functions are called sinusoidal functions. Okay, I didn't circle that well, but the word sinusoidal can apply to cosine or sine, okay? When you see that word, don't think it means I have to do a sine graph. It can be a cosine or sine. All right, again, amplitude is how far above or below the midline it goes. You can also find it is half the distance between the max and the min. And amplitude, because it is distance, is always positive. All right, we'll write that on the next slide for your notes too here. It says why is this not moving? There we go. The period of any sinusoidal function is the distance between two sets of repeating points. So you can start here as long as you go all the way down past that spot, and then when you get to that spot again, where it would start that over again. So one period is measured anywhere along there. Now, the period of this transformed function is 2 pi divided by whatever that b value is, and we'll talk about that in a minute. It is a reciprocal relationship, or called an inverse relationship. So the period is the length of one cycle you can start at any point. For the parent function, okay, it is 2 pi. Let's see, I have you, it's mostly measured in radians, or when we do applications, we will measure it in time. The amplitude is the half the distance between the min and the max. So you could do max minus min divided by 2. Or like I said earlier, it's how far above and below the midline. Now, for this form of the parent function, when you start putting a stretch in here, it affects the amplitude. And the b value in here affects the period, but the period is 2 pi divided by the b value. Now, super important, amplitude is a distance, so it's always positive. And b value that we take out of here is going to be positive as well. We're not going to do any with a negative b value, so it's just 2 pi divided by b. All right, this is from the book, and it talks about the properties, and I'm going to just go to the next slide and fill these in with you, but it's here if you need to refer to it. So one more time, the sine function starts at the origin and only goes up as high as 1. And by pi, it's finished the up, and by 2 pi, it's finished the down. So this is what it looks like. And going this way, it would be the opposite in terms of goes down first instead of up. So the ordered pairs you would need to list would be 0, 0, pi over 2, it was up at 1. At pi, it's back at 0. At 3 pi over 2, it's down at -1, and at 2 pi, it's back at 0. So those would be the quarter points needed in one period. The domain, though, is that it goes on forever left and right, so it's -infinity to infinity. The range, bottom to top, is only -1 to 1. Okay, it can only range between -1 and 1. Again, that has to do with the fact that sine is opposite over hypotenuse, so it has to be less than 1. The x-intercepts are 0, 0, and then it's pi, 2 pi, and 3 pi, and 4 pi. So we say 0, and you can add or subtract any multiple of pi as long as n is an integer. In other words, a whole number, positive or negative. So you could go -1 pi, -2 pi, and so on. You have to write it, you can't list them all because it just keeps going. So that's how we write it. The y-intercept, well, the only one is 0, 0. Asymptotes, it has none. The amplitude is 1, the period is 2 pi. And when we have transformations, it will look like this. F of x, I should probably use. And it will be a sine of b x minus h plus k is what we're going to talk about this year, I think. Sometimes they use c and d there, but I like the h and k. So amplitude is the absolute value of a, whatever this is, but it has to be positive to be a distance. The period is going to be 2 pi divided by b, okay? That is an inverse relationship. That's the trick. You got to remember that one. Any phase shift left or right would be h. Any vertical shift up or down would be k. And we are not going to do those today. All right, cosine, good grief, what is with my phone? Sorry. Cosine starts at the max, so that's 1, and it returns to 1 by 2 pi. Halfway in between there, it's at its min, and halfway in between there, it's crossing the x-axis. So it looks like this. So in one period, you would list 0, 1, pi over 2, 0, pi, -1, 3 pi over 2, 0, and then 2 pi, 1 for the quarter points. But it does repeat, so the domain is all real numbers. It still has maxes and mins at -1 and 1, so the range is that. The x-intercepts are still repeating, but they're different. They're at pi over 2, 3 pi over 2, negative pi over 2, negative 3 pi over 2. That distance from one to the next, though, is still a distance of pi. If you add pi, you would get 3 pi over 2 or 1.5. So they happen at pi over 2 or negative pi over 2, so you could write plus or minus, and then they repeat every pi. Kind of confusing. I'm not going to ask you to write that, but that's the notation. The y-intercept is over 0 and up 1, and it has no asymptotes. The amplitude is 1, the period is 2 pi. The transformations would be A, cosine now, B, x minus h plus k. And they really should have extra parentheses here. The amplitude is the absolute value of A because it's a distance. The period will be 2 pi over b. It's really absolute value of b, but we're never going to use a negative b. And this is h, okay, which is left or right. If you had a -2, it would be right. And a +3 would be left, just so we're clear. And the k on the end is the up or down shift, and that is not the opposite of what it seems. All right, are we ready to try these? Oh, almost. Okay. So the amplitude is the absolute value, or the max minus the min divided by 2, absolute value of A value. Period is 2 pi over B. Frequency, we are not going to address this year. Phase shift, they use C here. We used H. And this is about factored and unfactored. Don't have to worry about that today. Vertical shift is the max plus the min divided by 2, or it's where the midline is. Not going to do that one today either. We used K, not D. All right, this is the last important thing before I quit this little video. To graph a sinusoidal function, find the period, okay, which would be 2 pi over b, and then add the period divided by 4 to find the quarter points. Is the period divided by 4. And you would add those on if you had a shift, a phase shift, but that's not today. So we're going to use radians. We're going to find the amplitude and the period, and then we're going to graph, labeling at least 5 ordered pairs. And some of these also have a reflection. So can I just address that real quick? If you have sine x, it looks like this shape, starts at the midline. If they give you negative sine x, it is a reflected, so it would start and go down first and then up. If you have a cosine graph, it starts at the top, goes down and back to the top. If they give you a negative cosine, it is reflected, so it starts at the min, goes up to the max and back down. Okay, so those are the reflections that you might need to know. All right, I'm going to stop so that you have this overview, and then I'll have a separate one where I actually practice the shifts, or I'm sorry, the stretches for amplitude and period change.